Hey guys, welcome back. Today I'm going to show it to you how to write the equation for the function that models the data. So in my last video I showed you that if the first differences of y values is same, then it's a linear function. If the second differences of the y values is same, then it's a quadratic function. And if the ratio of these y values is same, then it's an exponential function. But I'm going to show it to you how to write the equation. So let's first find the first differences of y values. So you're going to take 2 minus 5, that's negative 3. 1 minus 2, that's negative 1. 2 minus 1, it's 1. And 5 minus 2, it's 3. As you can see that the first differences are not same, so this is definitely not a linear function. We're going to check the second differences and find out if it is a quadratic function. So let me check the second differences. So negative 1 minus negative 3, which is same thing as negative 1 plus 3, which is same thing as 2. Let me change this pen. 1 minus negative 1, that's 2. 3 minus 1, that's also 2. As you can see that the second differences of y values is same, therefore this is a quadratic function. But how do we write down the equation of the quadratic function? We know the equation of quadratic function is y equals to ax squared plus bx plus c, where a cannot be 0. For right now, I will explain to you in a minute. I'll tell you that if you divide this value, these second differences, which is same, by 2, you're going to get the value of a. So just divide 2 by 2, and you're going to get the 1, which is the value of a. Why do we divide by 2? I'll explain in a minute. But understand that this value is twice of a, so I have to divide by 2 to get the a value. So I know that a is 1, so y equals to x squared plus bx plus c. Now look at the table of values and choose where x is 0. Okay, that's the easiest value to plug in this equation. We still have to find the value of b and c. So when x is 0, x squared part is 0, b times 0 is 0, so you get c value. So c is 1, because when you plug in x equals to 0, you get c. So we know that c is going to be 1. So we used this value to find out c, which is 1. The only thing I need to find out is what is the value of b. So I'm going to pick another positive value. You can pick any other value, but I'm going to take the positive value. When x is 1, y is 2. So y is 2 when x is 1. And if you solve this, you're going to get b equals to 0. My final quadratic equation for the quadratic function would be x squared, b is 0, so you can write 0x plus c is 1, or simply you can write down y equals to x squared plus 1. This is the equation for the quadratic function. So let me tell you why we divided by 2. As I just told you, the quadratic function, the equation is y equals to ax squared plus bx plus c, where a cannot be 0. So if I use this equation and plug in x equals to 0, a times 0 is 0, b times 0 is 0, you get c. If I plug in x equals to 1, 1 squared is 1 times a, that's a, b times 1, that's b plus c. When you plug x equals to 2, you're going to get 4a plus 2b plus c. When you plug in 3, you're going to get 9a plus 3b plus c. So let's find the first differences now. If you find the first differences, a plus b plus c minus c, would be just a plus b, and you subtract 4a minus a, that's 3a, 2b minus b, that's just b, and c minus c is 0. Let's find the first differences. 9a minus 4a, that's 5a, 3b minus 2b, that's b, and c minus c is 0. So these are my first differences. Second differences are 3a minus a, that's 2a, b minus b, that's 0. 5a minus 3a, that's 2a, b minus b is 0, so this is 2a. As you can see that the second difference is same in a quadratic function, and it is twice of the value of this a, and that's why I had to divide by 2 in the previous question. Thank you very much.